In this video, we're going to be talking about the notes covered in section 1.2, part 2. We're going to start with a warm-up. As I will remind you while watching these videos, it would be best practice to pause the video before you see me work through the problems. That way you get the experience of doing the thinking for yourself. And then check back in to see how you did. So for the first couple, we're just going to really be practicing using proper notation, as well as reminding ourselves the specifics of domain and range. So as I look at part A, I know that the domain are the x values that are present in the function, the x values that were plugged in to get y values. And it seems to me that the domain, which are made up of x values, so what we're going to do is we're going to say the domain are all of the x's such that the x in question, right, is an element of what set of numbers? So again, let's think about what that says. The domain are all the x's. Okay, what specific x's? Well, the x's that belong to, and then according to the picture, it looks like we are including the endpoint of -3. And so we have our square bracket of -3 saying including, and we're going to stop never, right? So we go on to positive infinity for x. You can never include infinity because it is not a specific number. It is a behavior that just means it's growing without bound. And so we leave that open. And that's how we would talk about the domain. The range then is y values. It is the outputs of the function. And so I'm going to say for the range, we're talking about y values. And then here we're saying such that the y's that we're talking about belong to, technically, is an element of which group of numbers. And we always want to go low to high, lowest number to highest number. And it looks like, the picture is sort of a little ambiguous here, but we can sort of assume that it's definitely leveling out, but still continuing to drop. That was the implication. I just drew it too fast. So I would say that means we're going to start, we're going to be all the way down at negative infinity, and we're going to go and we're going to have y values all the way up to including the value of 2. And so that would be my range. All right. The domain on this one looks to be, again, with this parabola design, it's going up very big, but we do know it continues to go over. So I would say the domain are all of the x values such that x is an element of what group of numbers? And essentially what I want to do is I want to say everything but 4. Mathematically, there's probably a couple ways to do it, but we're just not going to get too fancy with it. We're going to say it includes all the values from negative infinity all the way to 4, but we're not going to include 4. And then we're going to pick things right up at 4 and keep going to infinity. Now, there's something we need to put in the middle here, and what we're going to put in the middle here is essentially the word or, also known as union. So in other words, what this means is I want to join those two groups together as if they are one single group. Okay, so I'm going to mesh them together, and the symbol we will use, the nice reminder there is U for union. So we've got like a U here in the middle. All right, and then the range are all of the y values such that what's the lowest y value we see? And it looks to be -2, but yet we don't include -2. So it's going to be -2 is my lowest, and it looks like everything above that, and it's never going to stop. And so we get this. All right, moving on. One more. Think this one through. There's a little trick here that it's not a trick to doing it, but if you're not being careful, you're going to get tricked by it. Domain I think most of our mistakes in math, I can speak for myself on this, don't come from me not understanding. It comes from me going too fast and missing things. All right, so the domain are all of the x's such that x belongs to the group. And again, it looks like we're going to start way over here at negative infinity, and we're going to go all the way over to positive infinity, except we don't have the value of 3. So negative infinity to 3, not including, and then we'll pick things up at 3 and keep on going. But I want to talk about it as one single group, and so I'm going to merge those together and say we're talking about one big group here. And then my range. Range is where we might make a mistake on this one, because we're looking at this and we're saying, oh, I don't have the value at the point 3,2, so we should leave 2 out. Seems logical, makes a lot of sense, except for when you remember, I got a value over here. Somewhere we pass through a value of 2, because later on I'm above 2, and to come back down to it, right? So to get from here all the way up, we had to pass through 2, right? So we have to think about that. And so my range is going to be all the y values such that they belong to the group. And then what does that mean then? Looks like we're going to go all the way down. We're going to go all the way up to here, bend back down, but then we're going to go all the way up again. So I would say it's all real numbers. And the way we would say that is negative to positive infinity. All right, so mainly we just want to get the notation correct on this, but also just make sure we slow down and think it through and don't fall for little things. All right, so we're going to just basically keep doing this concept, but now I'm going to have you do a little bit more of the heavy lifting and come up with the image as well. So part 1 here, example A, graph the function and state the domain by looking at the picture. All right, I'm going to turn on the graph paper. All right, we should remember that this is a square root function, and it is a square root function that has been shifted. So I know the traditional square root function, the parent function of it. So the parent function would start here. I know that it goes up 1 over 1. It's going to go up 1 over 1, 2, 3 more. Up 1 over 1, 2, 3, 4, 5 more. The pattern is going over 1, going over 3, going over 5. That would be the graph of y equals the square root of x. Roughly that. But with the x plus 3 on the inside, I know that it is shifting me over 3 units, and it goes in the opposite direction. Okay, so 1, 2, 3. So now I know my parent function looks exactly the same, but now it's just sitting over here. 1, 2, 3, 4, 5. And so my graph looks like this. Now, this one says graph the function. Ideally, mentally, you can graph that function, right? You can see it in your mind's eye, hopefully. If not, that certainly will help. Because there'll be times when somebody might ask the question, like I might write the answer down with no picture, and someone would say, well, did you graph it? And my first answer is, well, no. But then I'm like, well, I guess so, because it's automatic in my head, right? So I see that it shifts over. I know what the graph looks like. So this is a pretty easy question, right? And so hopefully you get to a place, if you're not already there, where you can just do that as well. All right, but now let's state the domain. So my domain are all of the x values such that we're talking about the ones that belong to the group starting at and including negative 3 and going forever. And when we talk about the range actually doesn't change. It shifts over left and right, so the previous range is still appropriate, which is hopefully obvious. We're talking about the y's that start at 0 and include 0 and grow forever. All right, part B, we have a rational function. And when we think about a rational function, we should visualize, again, a parent function. And if you don't remember exactly the specifics of it, that's all right. That's why we have tables of values. Everything else we do is shortcut, right? And so if you forget the shortcut, you can always rely on a table of values. So I know that the parent function, y equals 1 over x, has a vertical asymptote here and a horizontal asymptote here. And I know I have this point right here at 1, 1. I know I have this point here at -1, -1. And then I know really just the general shape. I don't even need to know the specifics so much. But if called upon, you should be able to come up with them. I know it's half and half here. So there's my basic parent function. So then what is this one going to do? It is going to shift +2 and up 3. So what I like to do is I like to take this little crosshair right here, the little intersection of the origin, and I think about moving that more than I think about moving the function itself. So I'm going to move the origin over to 2, 1, 2, 3. So now here is my new fake little x and y axis. And now what I'm going to do is I'm just going to draw the parent function exactly like I just did from this new location. So I'm not moving, this individual point right here. I'm not moving this point. I'm not moving this point. I'm moving this reference area and then graphing what I know to be the parent function from there. So I know we have the point at 1. I know I'm at 1/2, 2. And I know the general shape, so I can fake the rest really. And this. Now, by graphing the parent function, I have made this graph look kind of messy. But if we can fuzz out the red, then the answer is waiting for us. So what is the domain? It's all the x's such that we're talking about the ones that belong to. So it looks to me like we have every x value except for where the vertical asymptote is. And that vertical asymptote is now at +2. And so we are going to go from -infinity. We're going to stop at +2 and not include it, but then join it with the group that starts at 2 and goes to infinity. And then my range is going to be the y values such that they belong to, again, sort of the same concept, everything except for 3, because that's where my horizontal asymptote is. And so starting at the bottom, going all the way up to 3, joining it with the group that goes from 3 to infinity. All right. So that's us using a graph, but we also want to be able to answer this question without a graph. So this requires us to have a little bit of basic understanding of math and how things work. And so no picture involved. We're just going to ignore what's on the screen in front of us here, and I'm going to answer the question over here. So when I look at this problem for part A, f of x equals square root of x plus 3, I just have to ask myself some questions for the domain. What values am I allowed to use? Or you can reverse it and say, what values am I not allowed to use? And sometimes that's going to be the easier answer, because usually it's like, well, you can use anything you want. So what do we know about the square root of x plus 3, or the square root function? I know that I cannot take the square root of what? Negative numbers. 0 is fine, but I can't take the square root of a negative number. So what is it that I really need to ask myself? I need to figure out, in this case, when is x plus 3 going to be negative, right? When is it negative? That's what I need to find out, because that's what I can't use. So I'm just going to ask the math that question. So I'm just going to say x plus 3 has to be, well, I could do it 2 ways. You can talk about what it can't be, in which case, finding out what it can't be, you'd say, hey, when is x plus 3 less than 0? And then that's the stuff I can't use, right? Or you could have a more positive approach, and you could say, when is x plus 3 something I can use? Either way, either approach, I'm going to be able to look at and see that, okay, they're answering the right question. They just asked it maybe in a different way than I thought of it. So let's think of it maybe in the positive in this case. Okay. And so then I'm just going to solve this problem. I'm going to subtract 3 on both sides, of course, and I get x has to be greater than or equal to -3. So if x is greater than or equal to -3, that's going to give me an answer that makes sense. Okay, anything other than that, no solution. Okay, now once I've got the answer to the domain by looking at the picture, range is kind of a more complicated answer, if you ask me, because what I really need to do now is just think about what values I get when I plug in the ones I now have determined I can use. And so when I plug in -3, the lowest number I get 0. When I plug in then bigger numbers, I can easily tell just by thinking about how math works that as I plug in into the function -2, -1, 0, my numbers keep getting bigger, bigger, and bigger. I'm going to keep plugging in bigger numbers. I'm going to keep getting bigger answers. And so I just have to ask myself, what was the lowest value that I'm going to get? And that was 0, right? And so in that case, you can analyze the range as well. Okay, let's move on to the next question. Part B. So again, you just have to look at the specific function, have a basic understanding of math, and just ask yourself, and I think in this case I'm going to go with the what can't I do more than the what can I do. And in this case, what can't I do? There's only one thing I can't do in this case, and that is I can't divide by 0. So that would mean I just have to ask myself a very simple question. When is x minus 2 equal to 0? Whenever that is, I can't do it. So I solve and I get the answer of x equals 2. So what does that really tell us? And in fact, I guess we could have come back here and done it this way. We could have said, hey, when is x minus 2? Never mind. But I am going to interpret the answer and say x equals 2. But what I really mean is, hey, that's the value I can't have. Right? And if you go back and look at how we then wrote the domain, that's what we got. Every number but 2 is fine. Range, again, is more complicated. It does help to have a view or a vision of what the graph looks like in order to answer that question, because otherwise what you have to do is kind of go on a little exploration of what can you plug in, or what do you get when you plug in the values you can get. Another alternate approach, of course, would be to find the inverse of this function and then find the domain of the inverse, and then that should give us some clues on the range. We're not going to get that fancy. Really, it's the domain I want you to be able to analyze algebraically. All right, and now that's what we're going to do. Example 2. All I want you to do is figure out what the domain is and justify your answers algebraically. Okay, so again, I'll remind you, pause the video and try these yourself to get the full extent of the learning. So I look at part A, and I just ask myself that question, same question. What can't I do in this problem? And the answer is I cannot take the square root of anything negative. The 7 is fine, the minus is fine, the 6 is fine. None of that's going to affect what I can't do. The only thing I can't do is square root of a negative. So I'm just going to force it and say, hey, math, tell me when the inside of this square root function, when is it greater than or equal to 0? And the answer to that question will be the numbers I get to use. So I'm going to subtract 5 on both sides. I'm going to divide by -3, and I'm not going to make a mistake. I'm going to flip the inequality because I'm dividing by a negative, and I get x has to be less than or equal to 5/3. You'll often see me put like a double line under the conclusion of work, but not a box, because that's not the answer. The answer is what's the domain, and we're going to answer it using proper notation. So the domain is going to be all of the x's such that x starts at -infinity, it looks like, and then goes all the way to 5/3, and 5/3 is fine because that makes 0, and we can take the square root of 0. It's really easy to just check your work on a problem like this, because basically I'm saying everything from -infinity to 5/3 works, but guess what? If you forgot to switch this inequality right here, right, if you forgot that part, you're going to get an answer exactly the opposite of this. So certainly not a bad idea just to pause and ask yourself, okay, I'm saying everything from -infinity to 5/3. What's the easiest number I could plug in to check that makes sure if that works? and 0 is in that range. So I'm just going to mentally kind of pop up here and plug in 0, and 5 minus 3 times 0 is 5. Yeah, I could take the square root of 5. That's fine. Is that proof I've got the answer right? No, but it's at least proof I didn't do something silly. Because here, if I hadn't switched it, I would have said x has to be greater than 5/3, and 0 would not have, right? I would have thought 0 wasn't an answer, right? But actually it is. So that would have told me I'm going the wrong direction. Okay, part B. The only thing I can't do in this problem is divide by 0, and so I just need to know, when is this thing 0? So I'm going to ask myself the question. 2x squared minus x minus 3 equals 0. I'm going to choose to try to factor this thing. So 2x times x, 2x squared. Let's see, I'll put the 3 here and the 1 here. 2x, 3x, that subtracts. Yep, all good. I need it to be negative and positive. So now I'm going to do 2x minus 3 has to equal 0, or x plus 1 has to equal 0. Do the rest of this in my head. X equals 3/2, or x equals negative 1. But you got to remember, those are the things it can't be. So what's my domain? All of the x's in the region. Let's see. So negative infinity all the way to negative 1. Not including. I'm going to pick things up at negative 1, union, negative 1, and when am I going to stop? I can't use 3/2, but then I can use everything bigger than 3/2. All right. Hopefully that makes sense. Okay, part C's got a lot going on, or at least it seems like it. So let's stop and analyze. In the numerator, I've got no issues. I can do anything I want up there. Any x will lead to a y value. In the in the denominator, I have a square root. So I know that 6 minus 3x can't be negative, so I could say it's greater than or equal to 0, except since it's in the denominator of the fraction, I know that I can't make 6 minus 3x equal 0, because then that would be the square root of 0, which is 0. So that would be a problem. So what I really just want is, when is this greater than 0? And again, this time I'm answering in the affirmative, right? These are the ones I do want, the ones that are bigger than 0. So quick math, negative 3x has to be greater than negative 6. Again, we're dividing by a negative, swap the inequality, and I get 2. X has to be less than 2. Easy to check. Again, 0 is in the region that I'm saying works. I plug in 0. 6 minus 0, yes, I can take the square root of 6. We're good. So x such that x belongs to the group, starting at negative infinity, going all the way to 2, including the 2, not negative infinity. Okay, part D, I don't see a square root. I don't see a divide by 0. Those are the big two. Certainly, I'm not going to ask you about logarithms yet because we haven't reviewed those, but logs would have some issues. I don't see any problems whatsoever. Everything works. So am I doing this algebraically? Am I doing it graphically? I don't know that I know the difference. I do know that everything is fine. So I'm just going to say x such that x, and you could do this two ways, is an element of the real number system. Okay, the real number system is like a fancy R. Usually the way I draw it is I draw a line and then I draw an R over the top of it. Or you could stick with interval notation and say x such that negative infinity to positive. All right, one more. Okay, looking at this problem, I have a cube root. I can take the cube root of a positive, I can take the cube root of a negative, I can take the cube root of 0. Long story short, I don't care about that at all. Everything works there. However, I cannot take the fourth root of a negative number, just like I can't take the square root. So this just becomes the same question we've had. All I need to focus on is right here. So show the math, answer the question. I need to know when 5 minus x is greater than or equal to 0, and those are the ones I can use. Move the 5. And once again, we're switching the inequality. And so x belongs to the group negative infinity to 5. Okay, that's it. Hopefully that all makes sense. Most importantly, I want you to pay attention to communication. Can you communicate your thinking? All right. So that's what this assignment is really all about, especially these algebraic ones. Right. So I know that you can easily answer this question, right? You can do that in your head. You could probably figure that out. But I want you to be able to communicate your thinking to anyone who happens to be wondering about how you answered a question. Okay. So that is what this is about. Make sure that you are paying attention to that. And if you have any questions, please ask in class.